I am now alive. Hello world. Dun, 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 dun. Okay. Housekeeping. Refresh. And the YouTubes knows that I'm live. Excellent. There we go. 95 people watching already. G'day. Wow. That's a lot of peeps. Just let me get the chat up here. I could put the chat in pop-out chat. Here we go. Beautiful. Beautiful. Live chat. Give me all the chat. Hello from France. Ahoy me hearty. Yep, I got a cold. I sound like shit. Sorry. Thought I'd do it anyway. Indonesia. Brazil. Wow. Philippines. Argentina. Remember to set slow mode. What is slow mode? I have no idea what slow mode is. Rebo rotors? What is slow mode? Hang on, add source, general widgets. Hey, where'd all my sources go? What happened to XSplit? I used to have a... I installed an option to overlay the chat. Now it's gone. What the hell? Not happy about that. Install. Unbelievable. I hate computers. Installation complete. There we go. It's back. Right click to configure this source. Select event. Ah. Hang on, sorry. I gotta do some housekeeping. Unbelievable. What a load of garbage. I just authorized this before. Unbelievable. Oh. Two-step verification on my phone. I just did it. And I just put the option that said, never ask on this computer again. Hate computers. Hate them. Don't ask on this computer again. Unbelievable. Sorry for all this crap. Hey. There we go. It's hiding everything though. Alright, anyway. Sorry. Yeah, what was that slow mode? Slows down chat, does it? Well, there's no slow mode in the drop down box. Do I right click on it? No. No. How do I enable slow mode? I don't understand. I don't have the ability to go slow mode. Nah, I don't know. Sorry, people, I got no idea. I got no idea how to enable slow mode. So unless someone tells me. Yeah, sorry, I have. Unless somebody tells me how to enable slow mode, I've got no idea. I got no idea. I can't find it. So can put timestamps. Unbelievable. Okay, no one's gonna tell me, obviously. All right. Live dashboard chat module settings. Oh, that looks too hard. I don't care. Sorry. I'm just like, nah. I'm done. Whoa. That's heavy. Anyway, I thought that I would finish this Gigatron thing. So let's go. Dun, 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 dun. I should just ignore comments. People are just gonna chat among themselves. Alright. What am I doing? Left and right. Why does holding down control? Shift goes up and down. Shift mouse wheel goes up and down. Control mouse wheel goes left and right. And you can't right click and pan. Don't like that. How do you pan? How do you pan in this heap of crap? No, it's not Alt. It's not. It's not right click. No. Oh, you hold down the middle mouse. That's right. I hate that. I'm not a fan of clicking the middle scroll wheel. Not a fan. Not a fan at all. See, why can't I hold down the right button and then pan around? That's how like half the other programs in the world work. Like, you know, click and hold middle button. I don't like it. It's too much force required on the button. It's like not a natural thing to click the middle wheel. It like requires a lot of force. You know, maybe it's the mouse I've got. It's a Logitech thingamabob. Anyway. Hey, check this out. I got another camera. Oh, look, I'm a tag dag. Tag dag. All right. Okay, where was I? Yeah, because I never actually finished this, which is really silly. Anyway, this is where I last left off. For those playing around on EEVblog 2 before, a couple of months back, when I did this, I thought I haven't streamed on EEVblog main channel for a while. I just thought I'd do it just for kicks. 390 people watching. That's alright. Maybe I should tweet that. Tweeted. Okay. Did someone just say why KiCAD and not Altium? Because the original source file is in KiCAD. That's why. No, I'm not looking at alternatives. It just, for those who don't know, this is the Gigatron TTL computer, which you've seen in a couple of videos on my... Oh, bloody hell. No, I don't like how they've done the scroll wheel on this. Sorry. Just don't like it. This is the Gigatron TTL computer, and it is... you've seen it in previous videos, and I want to do a 4-layer version of this board. And the original designers of the Gigatron were kind enough to send me the KiCAD files. And obviously I'm not going to convert them to Altium just to do that, so I'm using KiCAD. So I've installed the new version 5.0000000. Yeah, there you go. And I'm using PCB new for those playing along at home. Alright, so where I got up to last time is I had removed the... No, what did I have done? What did I do? I removed the top and bottom layer, that's right. I removed the top and bottom layer. There we go. So that's the ground. Hang on. Maybe I just shouldn't even bother having the chat open. I don't know. How's that? Genius, I tell you. Because now you can see the menu bar on the left. I'm not sure if you can actually... Can you... Oh, yeah. Yeah, look. You can change the docking for this. Wow, okay. Uh-oh. 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 How do I redock? How do I redock? I don't hold down Control, Shift, Alt. It's not automatically snapping back. I've undocked that permanently. I'm not mightily bummed. I woke up this morning and I'm not good. There are no field zones. There are no field zones because these are, it's a ground plane. There you go. And there's no VCC, ground. Okay. VCC is not a thing. Where's my VCC? I've got a ground plane, but I don't have a VCC. So, drag title bar to side you want, just below the buttons. Oh yeah, there it goes. Ah, thanks. Yep, I didn't notice the shadow in there. Cool bananas. Hey, I can't make that any smaller. Why can't I make that smaller? Look at all this wasted space down here. Look at all this wasted space. I'm going to drag. Look, I can drag it bigger, but I can't drag it smaller. I can't drag it smaller. Got wasted space there. Look at that. Poor GUI design. Do. Alright, so, yeah. Why? Maybe I create. Did I create? I cannot remember. I cannot remember. So did I create that ground plane last time? Did I manually, when you create a ground plane, do you have to actually manually put in the, pour it in? Like, or not? KiCAD doesn't have planes, only filled zones. It's tedious. Thanks, Joshua. Look, I will say this once and once only. The TS100 video I had, I'm not going to explain it here. It's explained on the EEVblog forum. If you want to know my reasoning why I took it down, it's over there. I'm not going to repeat myself. I've already repeated myself 5 times, and I'm not going to do it again. Not on this stream, but I'm not going to do it again. I'm just not going to waste any more brain cells on it. It's not worth it. Ground plane must be filled manually. Okay, is that the same? I assume that's the same for VCC. Must be. It has to be. Right? If it is. Right. Okay, so I filled that manually. Okay, so. Front. I don't like how they use F for front. I just like, that's by default. Is that like a European thing or something? I don't know, because isn't it mostly written by Europeans or somebody? But it's like, yeah, F. I assume F means front. B means bottom. F means front. I don't like that. It's always top bottom. It's always top bottom. I don't. It's like F you. That's what that layer's saying to me. Like, it just FCU. It's funny. Sorry. It's my childish sense of humor. All right, so there's bottom layer. And there's our front layer. Screw that. Top layer. And ground, I've already put in a groundy doodad. All right, so that means that, let's actually just go in. Have a look. Yep, okay, it's already done the thermal relieves. Yep. Okay, it's already done the thermal relieves to the ground plane. So, now what it's missing now, of course, you can see all these white lines. These are the missing nets. So, yeah, all I've got to do is pour my VCC, I think. It should be right, and then we should be good to go. So how do I pour a fill? Place. Is it a polygon? Is it a polygon? Or is it a B to re-pour? I've got a cheat sheet here. No, B is begin, but oh, sorry, no. They're different for schematic and PCB. My cheat sheet does not have B for re-pour here. Maybe I've got an old cheat sheet or something. Place zone, is it? Joshua seems to be the man. Create fill, select net, draw polygon. Create fill, select net, what? Place zone. Everyone. Place zone. Oh yeah, zone looks like a fill. Okay, so they call it a zone. Okay. Groovy. So I'm going to have some pullback on there. Alright, you have to have some pullback. Tip for young players, never take your ground planes to the edge of the board or outside, even if the tool automatically has a thing to trim. I don't know if KiCAD has the ability to pull back. Choose our layer. But even if it does, I would recommend not relying on it. Okay, thermal reliefs. Yep, solid. Through-hole thermal. I wonder what the difference. Maybe we can play with that later. I assume THT thermal is through-hole thermal. What's going to be the difference between the through-hole thermal and the thermal relief? I wonder. I think you're wrong, Gabriel. It's not polygon. It's a zone. What is a pullback? That's a good question, Digital Hands. Okay. I didn't finish my thought there, did I? Fundamentals of PCB design on my channel. There's lots of I've done walkthroughs. I've done like an hour, I've done hour-long walkthroughs of designing a PCB with lots of hints and tips along the way. Sorry, I don't know the name of it to hand. It was one of my power supply design series videos. It's labeled Power Supply Design PCB Layout or something. And I've done... Right, so, anyway, let's go out of here for a second. Okay, when you've got a PCB, right, you've got the edge of your board here. The edge is defined on this particular layer. I don't know which layer they use in KiCAD. Fabrication layer, is it? No, it's not the fab layer. Bottom fat, no. Mask, pad, adhesive. Edge cuts, there we go. They got an edge cuts layer, right? So your board is defined by... It doesn't have to be on the edge cuts layer. It can be on the copper layer. It can be anywhere. As long as the PCB manufacturer knows, they know when they see lines like this on, it doesn't matter what layer it is, they're going to know that you're implying that that's the edge of your board. Now, the edge of your board, right, when they manufacture your PCB, right, they use either routing or big guillotines or saws to chop your board up, right? And when they chop your board up, especially if it's a multi-layer board like we're designing here. We're designing a 4-layer board. So that means we've got the top copper, the bottom copper, and ground and VCC in here. Okay, so what we're doing at the moment is we're actually creating these 2 inner layers, ground and VCC, and they're just one big solid copper plane in this particular case. Doesn't have to be. And they will, by default, in a lot of packages, in this case, KiCAD does not have planes as such. They're just layers with polygon fills or zones in this particular case. So, but anyway, right? If you draw them all the way to the edge, like I can't, my snap doesn't go in there. It doesn't snap to object. Anyway, if you take your plane copper plane all the way to the edge of the board where the board gets routed or sawed or cut off. Then, if you've got the copper in the inner layers, when they do that, when they slice or route through it, it can cause little burrs in the copper. And then the copper, if it's right on the edge of the board, can... Yeah, if the copper's like right on the edge of the board, like that, it's right on the edge, and they route or they slice your board, it can actually short those two layers together, right? Because you can get little burrs, and they can short together. And obviously, if you short your power plane and your ground plane together, that's going to ruin your day. So you don't want that. So what pullback is called, right, is I do not want to define the copper going right to the edge of the board. I want to pull it back a distance from the edge. And a package like Altium will have, you know, it knows what planes are and it knows what pullback is and all that sort of stuff. So you can define that. KiCAD, I believe, doesn't, what I'm told here, KiCAD doesn't have that ability, so you've got to do it manually. So that's why I'm going to select, rather than go right to the edge, I'm going to leave a gap, pull back around the edge of the board. That's what it is. So, thermal relief. I don't think I ever asked. Yes, I'm sick. Sorry. That's why my voice is crap. I just woke up this morning and it's fine. Last night, woke up this morning and probably picked up something from the germ factory yesterday, preschool, for those who don't have kids. It's the germ factory. All right, so net. So what we're going to do is we're going to, right, hang on. We're going to place. So we're going to place a zone, and we're going to pull back from the edge. We're going to select the layer we want, VCC, which is our power, and then we select the net that we want. So I assume they're not in alphabetical order. Why aren't they in alphabetical order? Hidden net filter. You know, we can just use the net filter. Apply filter. Alphabetical. It must be called something else. Okay. Okay, it's probably called +5 or something. H. Oh, that's right. That's right. They yeah. KiCAD is weird. Not KiCAD, sorry. Yeah, the designers of the Gigatron. Where is it? How do you sorry. Not very good at this. Gigatron schematic. Create, yeah, I think because I'm using version 5, we're not found. Transistor lit. Well, lots of libraries weren't found. That's not good. Okay, and remap symbols. Project Rescue Helper. I think because I've got an old, that was done in an old version or something, so oh, sorry, it's doing this off screen. I can't. Whoa. This is heavy. Okay, so it's mapped. Backing up rescue. Oh, God. Oh. It's done. It's remapping, resaving, backing up files. Oh, God. Okay. I don't like this. Don't like the sound of that. Doesn't instill a lot of confidence in me. Anyway, KiCAD, sorry, not KiCAD, the designers of the Gigatron, they, how do I change sheet, how do I change sheets? Anyway, hierarchical sheet project, there we go, haha. I am now a KiCAD expert. It looks like they've got hidden power pins on there, do they? They must have, they don't have power pins on their chips. They don't have power pins on the schematics. So that must be over on... Yeah, where's my hierarchical list of schematics? I so don't know how to use this. Must be painful to watch for those who have a clue. Gerber's Gigatron Pro. Anyway, like, people are probably screaming at me. Abort. What? Right click. Exit sheet. What? Leave sheet. Oh, okay, thanks. Peripherals. Power. Power. Clock. Hierarchical sheet. There we go. There we go. We're in like Flynn. Alright. Drag. I'm getting used to it. Yeah, they've named... Took me 5 minutes to get to this point. They've named the nets here high and low. So, somebody just beat me. It's not going to be Mr. Christopher J. Gamble, is it? I won't jump. No. Okay. No, I'm not going to do that. Alright, so high, low, right? And yeah, so they've labeled them high and low. And yeah, it's Chris. It's Chris Gamble. He's not a happy camper that I don't know how to use KiCAD. Should I embed Chris's chat window up? I don't know. Anyway, yeah, they, instead of labeling them ground and VCC, like they've labeled them look, the problem is I don't want to. No, see, no. Hang on, sorry. Hang on, I'm just going. Sorry, I'm just going blank for a second. Sorry, I'm back. Just some housekeeping there. Here we go. Hang on. I don't want to... Hang on. I just want to get... Okay. Sorry. I'm just going to screen capture. Ah! Bloody XSplit still has this bug. It still has this bug that I try and capture a window and it shows up blank. It's the bloody accelerator thing. Stupid, GPU. I think it's a GPU related acceleration thing. And it's just dumb. It's just dumb. Sorry, I can put him over here. There he is. There he is. There's Mr. Gamble. Say hi, Chris. He's watching my live stream. Hi, guys. Wave to Chris. Yeah. I knew an OBS fanboy would immediately jump in. Good on ya. You win the internet. Unbelievable. I think your audience might know just as well anything I know. Anyway, I can't leave your chat window up there because as soon as I click on this stupid thing, it's gonna go. It's gonna vanish. See? Dumb. Anyway, yeah. Hi, Chris. Bye, Chris. Oh, no. He's about to say something profound. Has the green dots there. Everyone's waiting. Chris, make it profound. Yep, makes sense. I'll keep watching as a spectator. Okay. Bye. I just deleted my Amp Hour co-host. Anyway, back to this. Yes, they labeled them high and low. Okay, it's fine. Like as long as you know. I don't know. I've never ever seen anyone do that before. H and L. Is that like a thing? Has anyone ever seen somebody do H and L before? High and low. Maybe because it's digital only. And it's a digital only board. There's basically no analog on it. So it's like high and low. Makes sense. Yeah, just haven't seen it before. Yeah, VCC and ground, of course, I'm sure. Nope, never seen H&L on a digital board. Never seen it. Nope. H on old tube schematics. Oh yeah, you'll get H plus. That's or you get HT. HT for like high tension. On old tube stuff. That was common. You see it on homebrew stuff all the time. $5VF for fused, yeah, like I would understand that. Like if I saw $5VF, it wouldn't take me long to guess that that's fused. H&L sounds more like a can than a power rail. Yeah. Anyway, there you go. We got sidetracked enough. H&L. So that's the net I need to. We've already done L, because the only nets we're missing, based on these white net lines, these white that they tell us that they're unrouted nets. That's the term I was looking for. They're the unrouted nets, and I guess KiCAD by default has unrouted nets on, which is great. So I've explained pullback. So let's go in and let's place our zone again. Once again, we've got pullback. We're putting it on the VCC layer. I'm not going to rename it H. H, apply filter. What? Alphabetical. Anyway, high. H, there we go. Right. So we're going to do thermal relief. As I said before, I don't know the difference between thermal relief and through-hole thermal relief. But I did thermal relief before on the ground plane, I believe, and that seemed to come out fine. But we can change that. I'm not sure what the default difference is there. I wonder if you can set those up. I wonder if you can actually define... Are they fixed in KiCAD? Or can you go in and like have a user-defined pad connection? I'd like to know that. Like, I assume that you can set the diameter or like the width of the traces, whether you want two connections for your thermal relief that goes horizontal or vertical, or whether or not you want a cross, or whether you want diagonal, or however you want to yeah. So anyway, thermal relief. Enough dicking around. We're gonna connect on the VCC layer to H. Ta-da! Oh no, there it is. Sorry, arbitrary. There you go. You can define it. You do it in here, horizontal and vertical, and 45 degree only. There you go. So I answered my own question. Outline style hatched. Fill mode, polygon or segment. Boundary mode, low resolution, high resolution. Not sure what that is. When it gets towards a boundary condition near an edge, it maybe takes longer to process or something. Corner smoothing. Oh, chamfer or fillet. Clearance, minimum width. Okay, we can do our, yes, of course, it's all in here. I should have just looked before I started yapping on saying, you know, I wonder if it's got all this stuff, and it's like right in front of me. Oh, dearity. Anyway, and it has all the stuff I was talking about right in front of me. Yes, someone mentioned it. No Como mentioned it there. Anyway, yeah, all the parameters are in the window. Exclamation mark. Alfredo knows. Export settings to other zones. Okay, cool. Anyway, let's not dick around. Right, footing hatched. Yep. Outline style. Good old hatched ground plane. People don't do hatched ground planes anymore. That was all the rage back in the 70s and 80s. Anyway, here we go. So, we're creating our zone. I won't say polygon, because polygon is a different thing, isn't it? And we've got our pullback. I'm not sure the distance of that pullback, but who cares? It's good enough. Not even sure what grid spacing I'm using. Where is it? It's down the bottom somewhere. DX. Grid. 1.27. 50 mil. Cool. Da-da-da. And ta-da. And there we go. I assume we have to go back up the top, or can I just right click and get out of it? And it will complete. Ta-da. There it is. There you go. And it's already... I like that feature. I like that feature there, that it shows you that it's, you know, it hasn't bothered to fill in that. I guess it's kind of neat. It's a little bit visually messy, but I do appreciate that. What's going on here? What's going on here? Some silly buggers happening in there. Do they have like invisible pads or something in that footprint? What's going on there? Anyway, it has joined. There you go. It has joined all those in there. And why do we have an unrouted net? Why do we still have a few unrouted net connections? Maybe they're on the top side. Look. A few of these white lines. The heart feature turned on. It's called the love heart of death. Okay. You can't set clearance between tracks of different classes, really? Sorry, I'm just going to ignore all questions not related to what I'm doing. Sorry. I don't want to get sidetracked. Right. Try and hit B. Oh. I did hit B and it just rebuilt. What's it doing? Sorry, I missed that. Loading zones. It rebuilds the zone. Okay, great. All right. So we have some something weird going on here. Well, it's not weird. It's obviously there's a reason for it. Okay, so there's our low. Oh, okay. Oh, okay. There's a couple of low ones which weren't connected. No? Yes, they are. Okay. So they're nothing to do with VCC. Or high. This one here is, look. High. Look. H, right? So, oh, look at that. Look at that. We have a DAG. We've got a DAG. We found it. Oh, sorry. I'm using the wrong scrolly thing. Where was it? Hang on. Oh, I lost it. There it is. There we go. Look at that. We've got a genuine DAG. Little bit of track in there. So it's going... So if we did a DRC on this, a design rule check, it would say that you've got some floating copper. I don't know what it would call it in KiCAD. But, you know, that's basically... It's floating copper. It's unconnected copper. So we want to kill that. And our trace goes away. So we're in our... Basically our tidy up phase of our PCB. Let's assume that we had just routed this. And then we're in the point where we're just making sure all of the nets, we've connected all the nets, we've got no unconnected nets. You might, at this stage, do a DRC, and you might get a report, and you might put that on a second screen so that you have your report there, and then you just go through, and you might have 20 things that aren't connected because of that floating copper you had there, or, you know, some other issue, or something like that. And you just go through and tidy them all up until you get a DRC, 0 DRC errors. And then there's lots of other things before actually releasing your board. But anyway, why doesn't L come in here? Is there a... No, because we're using a ground plane, so it should work. So ground and VCC. Yeah, look. Why is it going over? Is there another bit of daggy copper out here? Bottom copper. Yeah, there we go. Another DAG. It's another DAG. That's left over. That is totally unsurprising. Because this... No, it's not, actually, because they use zones, and I just deleted the zones, because this was originally a 2-layer board, okay? And they would have filled in the copper, the positive and negative rails on the 2 layers, on the top and bottom layers, as zones, as fills. And yeah, look, yeah, we've now got a bunch of... Oh, don't want to flip. Yeah, we've now got a bunch of these, see? Got a bunch of floating coppers, so it's a bunch of DAGs. So even though I actually deleted those, it shouldn't have left little residual DAGs like that. So that's really rather surprising, you know. There's another one down here, right? So I don't know where these little residual DAGs came from. Isn't a big deal. What is this? What is this? Is this some sort of registration? Like, you know, test, coupon? If so, I don't really understand it. Okay, that doesn't even match the trace width, you know? That doesn't even match the minimum trace width. So I'm not sure what's going on there. For those who don't know, often you'll usually do this outside the board. You usually won't do it on the board because it's just visual pollution. Is that, well, some people do, and it's fine. You'll have a test coupon. It goes by various other names, but you'll generally put it on the outside of the panel, and you'll put things like the minimum trace width that your manufacturer can do. So you'll put a couple of lines on there to set like minimum trace and space and stuff like that. And you might put some alignment markers for, you know, you might put some silkscreen over the copper, for example. And what you do that for is that when you get the board back from the manufacturer, you can look at the test coupon, and it's got all of the information in there you need to check the manufacturing quality of that board. So you can see, you can go, so you put it under the microscope and you have a look, and you can see the alignment of the layers. You can you might pull back your copper there so you can see all through the different layers. and you can see the alignment of the masks and everything, solder mask, your silkscreen top and bottom, your copper, you know, stuff like that. Whether or not they've over etched or under etched, you can get in there with your micrometer and you can actually measure. You know, if your 4th thou track is actually 4th thou, you know, how much they're out by, have they over etched the thing, you know, all that sort of stuff. So it's common to add a test coupon for this board. I don't care, right? We're not pushing the envelope here. But if you had a board that had, 3 thou tolerance or something, you know, you're really getting down there to like a real dense board, then you'd maybe want that, because especially if you've got a big, large, complex board and you know, everything's really dense, you've got really thin traces, you've got really fine pitched stuff that need really good alignment, you know, big, 2000 pin BGAs and stuff like that need real critical alignment on the solder mask and all sorts of things, then a test coupon is absolutely vital. So on a professional board, you would do that. So that's just something that you'd do. So anyway, there's another one. We got one. Let's go around and get all the dags. I'm getting used to this. I'm getting used to it. Another dag. Oh, no, I thought, nah, that was a silk. I thought that was a silk. That's a silk screen thing. Oh, look, naughty. Uh-oh. Greater than 90 degrees. Bad design practice. Dock your day's pay, as an old colleague of mine used to say. If you did that, I'd dock your day's pay. It just goes back to the old, the reason that you don't do that, have sharp angles like that. It's not so much an issue these days because the process tolerances, like the process controls are really good on manufacturing boards these days. They're just stunningly good. But, back in the old days, it's still the case these days. When the board is in there, when the board's in the etch bath getting etched, sorry, I'm not good. And the etchant, they use like a bubble etch, so it's all bubbling around in there, right? So it's all swooshing around. So when that etchant, either ammonium sulfate or ferric chloride, I don't know if they use anything else in industry. They might be some special mixture. Anyway, it's all agitating in there, right? So the swell of the etchant in there, when you've got sharp angles like that, it can sort of it builds up in there and it can etch more away. So in theory, you could actually get over etching in that particular space there. So that's why you don't want sharp angles like that. You have 90 degrees or nothing. And then a lot of people will say, oh, I don't even like 90 degrees, because that's also it's also called an etchant trap or an acid trap. And so if you've got really sharp angles like that, all the etchant, in theory can sort of even though it's only really thin, right? And it generally just washes over the top, it does actually potentially etch away more of the trace in there. If you've got really thin traces, you can get breakthroughs on your traces, or, so it's really bad. So that's called an acid trap or an etchant trap. And so some people would think that even 90 degrees is an acid trap, right? So they'll put a fillet in, they'll put a chamfer, right? And PCB packages will have options. They chamfer all of you, they'll auto chamfer your traces for you. And some people like that look, and I don't blame them. It's pretty funky. I probably went through a fillet phase, and the other thing is teardrops as well. Now that we're talking about this, see the problem here is this trace here, right? So coming down on this trace here, right? This is not good layout, right? You don't have your trace coming down and then at an angle, even though it might be angling in here properly and it might be physically connected. I don't like that KiCAD doesn't actually. Oh yeah, look, see, that's really bad. oh no, there it is. It's hidden. See, I didn't like that was hidden, right? So it's going to the center, which is all great, okay? But then you've created the acid trap in there, right? It's just not good design technique to actually do that. So I don't know if we can, I don't know how to move, you know. Anyway, yeah, so that's not good layout practice to go like that. So, yep. Never enter, basically never enter, the rule is never enter a pad at anything but 45 degrees or 90 degrees, right? In this particular case, we're entering sort of like, well, we are entering at 45, but it's coming right down and touching it. So it shouldn't. It should have come down like that, maybe gone in like that, and then down. So, you know, like it's just minor thing. And then there's minor tidy up things like this. Like, you know, if I was a PCB, well, I am a PCB designer, right? But if I was laying out, what I meant to say is if I was laying out this board, right, I could not live with this, right? As a professional PCB, I could not live with that. I would have to tidy that up, right? So I'd drag those flat. Like, there's no reason to have them going like that. There's no electrical reason why that's a problem. Okay, it's not. It's visually. So, you know, stuff like that. But by the way, don't be harsh on the guys who did this, because it was their first rodeo. This was like that. They learnt to use. I believe they said that they learnt to use KiCAD. This was like their first layout, like, ever. You know. And look, other things in there, that's just going straight through. That's really, you know, that's a bit how you're doing, you know. So they did really well for their first board ever. Here we go, got more dags. Looking for dags. Another one. I guess we should just do a DRC, right? Anyway, how many people we got these days? Where's the window? How many people are watching? Run the DRC. Yeah, it's not necessarily and maybe it is an OCD thing, but you know, it's just taking pride in your PCB layout. You know, any professional PCB designer will have pride in their layout, and you know, just oh no, I thought I saw another dag. You know, having something as simple as that, right, would like just show that you don't care, you know, and like it wouldn't matter to anyone. Like it's just, you know, it's purely a self-satisfaction thing. But anyway, they've done a pretty good job on this layout. Like. It's their first time doing anything, and I'm really impressed that they actually got the, you know, the routing, the placement, and everything is really quite decent. So it really is a good job. Oh yeah, there's those other pads. There you go. Yeah, that explains that. There you go. Oh, what's that mode that makes KiCAD look like visually perfect or whatever? What is the what, if anyone knows what I'm talking about? I did it in the previous video and I completely forget. Yes, the what you see is what you get mode. Yeah, OpenGL, press H. I think that's it. Is it? Yeah. No. No. See, I want it to... No. Alt 3. Oh, 3D viewer. No. I don't want 3D viewer. Press F11. F11 does absolutely nothing. No, it's just like it doesn't look like the real deal, right? View menu. That makes sense. Drawing mode. Fill zone, wireframe, sketch. Fill zone. Sketch pads. H. High contrast mode. Yeah. Oh, no, that's the... Yep. No, we've done that. Anyway. Right, so how do I run a DRC? Design rules checker. Rules. Design rule or rules? Oh yeah, we can measure shit and list nets. Groovy. Okay. Anyway, whoa. Whoa. There's my board. Alright. Design rules checker. Oh no, hang on. Interactive routing settings. See, hang on. I just want to try. Whoa, look, there's another non-right angle in there. Sorry, I'm just dicking around now. I want to how do I tidy that up? No, I don't want to. No, I don't want to because no, the whole idea of doing this is so that it's exactly the same layout as before. It's exactly the same. I changed nothing. So I don't want people going, oh, but you moved the traces. Alright. Single layer pair. Scripting console. Select copper layer pairs. Nice. Okay. Inspect. Design rule checker. How do we switch modes? How do we switch from imperial to metric? Metric to imperial. Can we do it inside... Oh, D is for dragging traces. Thank you, Vincent. Yep, drag, track, keep, slope. Yep, it's in my cheat sheet. There's drag item and drag trace. Yep. Drag item is G. Another blob of copper. Right. Inches a minute. So I can't do it within here. See, if I was inside Altium, I'd be able to hotkey it. I'd be able to hotkey imperial metric straight with inside the dialog box. Micro size, anyway. So, left toolbar, inches and millimeters. Yeah, doesn't do it inside the dialog box, you see? I'm actually, sorry you can't see it because it's under the chat window, but I'm actually clicking on the millimeters and inches thing, and which is fine. But it doesn't reflect in the open dialog boxes. So maybe that's a, you know, it's a programming thing. There we go, inches. Minimum trace width. So, give it to me in thous. Like, seriously, when you're doing DRCs, KiCAD developers, when you're doing a DRC, you're not working in inches, okay? You're working in thous, 1,000th of an inch. By having it display 0.0078 is ridiculous. This should not be in inches, it should be in thous, 1,000th of an inch, okay? That's just silly. That is absolutely silly. Please change that. That's just insane, right? I don't want to have to be dicking through multiple decimal places. That's visually, that's terrible. Muriel. Please fix it. Anyway, so we're talking, 7.8 for those Imperial fanboys. We're talking about 7.8 thou minimum track width and minimum via size of 15.7. Track width, where's our spacing? Like, clearance by net. Clearance is by net class. Wow. Okay. Right. And we can't click on that. Oh, look, you can just go list unconnected pads or tracks. Unconnected items. There you go. Pad 16 on FCU. Internal, non-copper. Can we just click on that? Yes, there we go. Found our DAG. There you go. Found our DAG. So that was the unconnected thing. How do we get back to our dialog? Oop. See, our dialog box is gone. That's no good. I want my dialog box to stay open, please. Because if I've got this dialog box on another screen, if I'm a professional designer, right? I got my multi-screens and I'm doing the business, right? And so I've got this thing, it's half off the screen. So, it's on the other screen here, okay? So, list unconnected items. There we go. It did that not refresh? See? It popped up, right? Maybe understandable. But I go click on this, right? I want to jump to this. And my dialog box vanishes. Why? I want the dialog box open, please. I want it left open. We've got another DAG. So it's finding all our DAGs, which is good. And, yeah, so it calls them unconnected items. So, items, like item. It doesn't know what it is. Of course it knows what it is. It's a track, right? It's got an unconnected copper. It knows it's copper, right? So, anyway, unconnected items. But I guess when you're doing DRC, but you can do DRC on silkscreen and solder mask layers, so, it should go unconnected copper, because it knows it's not an item, it's copper. Unconnected count. Okay, list unconnected. We can redo it. Anyway, there you go. Boop, and takes us in. The thing is, it doesn't zoom. See? It doesn't zoom. Right? Here's another thing. Right? If I'm out like this, right, and I'm off over here with the fairies, right? If I'm off over here with the fairies, and let's try this. Design rule checker. I'm sure there's a shortcut for that. List unconnected. Why did that change? Oh no, okay. So it's centered. Oh, the good thing is it centers. Look. Okay, so that's nice. That's nice. Unfortunately, we don't have multiple ones anymore. I could go in and create multiple ones just to show you. But every time you click on it, so I assume if we had the list back here and we clicked on it, it would move around. But you notice it doesn't zoom in. So I can't see diddly squat detail on that. I shouldn't have to set the correct zoom level first and then, do that. Like, it should at least go to some manageable zoom, some workable zoom level so that I can see the thing that's failing. Okay, so now I've got to go in, and now I've got to go like that, right, to see it. And when you've got a big list of stuff like this, you want to have your dialog box off in the other screen. You want to click on each thing, and then you want it to, just jump around the board to see what all the errors are and stuff like that. So, yes, KiCAD developers, please add that ability to do that. Okay, so we're good, right? So we're good. List unconnected. So we've got diddly squat unconnected. Beautiful. So everything's hunky-dory. So if we start our design rule checker, boop, 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 pad clearances, track clearances, check in zone fills, zone-to-zone clearances. We don't have any of those because we don't have multiple zones on multiple layers. unconnected pads, keep out areas, test text, items on disabled layers, finished, and we're good. Yay! In theory, we can just go get it manufactured. So now, oh, keep clicking the wrong thing to scroll around. So anyway, now we've got our, like, so that's our top copper. There's our bottom copper. And we've got our VCC plane, and the thermal reliefs look good. No wuckers. I can just see them. Sorry if you can't see them. There you go. So, yeah, no problem whatsoever. That's not going to cause a problem soldering wise. You know, we could. I don't. What's the thickness of those? They're like 15 thou traces. 15 thou. V reliefs. Can we? Oh, there we go. How do I edit? How do I edit my zone? I can't double click on my zone. Why can't I double click on my zone? Help! I have to click the edge of the zone. What? Really? Okay. Even if there's nothing else, even if I've got all the other layers turned off, right? Whoa. Just slow down there for a second. So even if I've got all the other layers turned off, there's nothing else under here. You're telling me that I can't double click on that. That sucks. That's just terrible, Muriel. That is terrible, right? I cannot, like, even if you have multiple items there, when you double click on it, it should pop up with a box and say, which item would you like, sir? And it, like, yeah, you know, small things like this, just, you know, spit and polish. You know, I'm not saying it's bad, right? But it could be a lot better, right? To have to go to the edge and select it like that, just to get in there. Oh, see, I can't even. Then how do I zones? Then how do I edit my zone? I've got my zone selected. Damn it! Is there E for edit? I'm exactly pointing all these things out. Free and open source is terrible on spit and polish, yeah. Well, you know, like it takes a long time to get spit and polish. E for edit. That makes sense. Let me my cheat sheet. My cheat sheet doesn't have E on it. What? I'm using some shit cheat sheet, obviously. All right, there you go. So, did we actually find out what this is? What the difference is? THT thermal. Did we actually? Doesn't look any different, does it? It doesn't look any different. Clearance, minimum width. 45, hatched outline. Anti-pad, spoke width. Yes, 20 thou. Yeah, that's a lot, isn't it? Jeez, you know, you can take that down to 10. Must be greater than the minimum width. Oh, yeah, fair enough. It's just testing. There you go. little bit thinner. A little bit thinner. 15 thou, 20 thou thermal relief. That's pretty chunky, you know. So, just for completeness, you know, for OCD reasons, we'll do that on our ground plane as well, or our L bus. There you go. No wuckers. There you go. 15 thou. Plenty. Plenty. Alright. So we're good. Oh, I should bloody save this, shouldn't I? Haven't crashed yet. I don't really want to save as. I just want to save 4-layer PCB. Yep. Yeah, happy with that. Just save it over the same file. Right. Jeez. Yeah, lots of clearance around there. No wuckers. Alright, so we're probably good to go. You know, I could do a lot more checking and stuff, but really, I think that is fine. Hang on a sec. Sorry, just doing your regular programming will resume shortly. Ta-da. Sorry about that. And what do we got? Wow, 637 people watching. That's pretty good. Alright, so where was I? So yeah, we're good to we should be good to go. Because the whole idea is that I didn't want to touch anything. Didn't want to touch a thing. Except convert it to a 4-layer PCB. And I don't want copper on the top or bottom. I don't want any copper fill. Because the whole idea, for those who don't know, the whole concept of this is that I want to show the difference in EMC, in radiated emissions of a 2-layer board with ground fill top and bottom, you know, just like fill in copper everywhere and higgledy-piggledy, against a solid ground plane. And I think this could be quite a good example of that. So, yeah, you can get a better example, but I'd have to manufacture. I'd have to design a better example. I just have this one to hand. And I think it's good. So it passes all the DRCs. I think we're good to go. Geez, we don't have much... look at our poor vias there. But I'm not gonna change anything. I'm gonna leave it, right? I would have had because you risk a breakout there, okay? So your annular ring around the via there, right? That I don't know. I could go in there and measure it, right? I could. There it is, right? There's inches. I wish you could like toggle between inches and millimeters in the dialog box. That'd be really nice, right? And so we've got a 23 thou pad with a 15 thou drill, 15.7 thou drill. So you know, it's good enough, right? But anyway, I wouldn't. That's not, you know, that just looks a bit thinny to me. So anyway, I'm not going to touch it. The board's going to be the same. So let's so we're good, right? We've saved that. I don't think I have to do anything else. Like, this is not a production board, right? I just, like, this is a one-off. I just want one, right? So I'm going to, so I'm not going to fuss over other things. I've done my DRC. It's all connected. It should work. But it's a 4-layer board. And, yeah. Like, and we don't have to worry about, like, other stuff like, you know, actually connecting, like, the ground, you know, the 15,000. Oh, look, it's added chamfers. Oh, look. Isn't that pretty? Look at that. It's added the chamfers. Oh, was that an option? Was that a secret option? And it's rounded them too. Isn't that groovy? All right, maybe that was an option in that polygon fill box. Anyway, like stuff like, you know, like we're not talking high currents here, so, you know, having four traces at 15 thou actually connecting through to the ground plane and everything else, that's, you know, it's fine. Don't worry about it. So we're good to go. Oh, 3D. Everyone wants a 3D viewer. Yes, we should. Yeah, before you get anything manufactured, thanks for kind of reminding me, we should actually have a look at the 3D view. There you go. Because the best thing about the 3D view is it's what you see is what you get. You can see the solder mask expansion on the pads. Like, you can see, you know, you can see that sort of, like, I know you can test these in DRC, but there's nothing like actually looking at what your board is going to look like, right? Absolutely nothing. Actually, let's just hang on. So how do I doodaddy it? There we go. That's how I doodaddy it. That's a technical term for technical term, doodaddy in. I just hold down the left thing, so that's all groovy. You can see exactly what you're getting. There's no silk screen on the bottom. You can see exactly what you're getting. How far can we go in? Can we go into the layers like you can in Altium? Nah. Yeah, a few little artifacts. A few little render artifacts around there. You quit open source projects. Thank you, Stone Cold 7. You're my biggest fan. Yes, I did a DRC. It passed. And anyway, yeah, so groovy. I was about to say, we need to add some frontside silk. We need to add, get rid of that pesky copper. So how do I place text? DaveCAD. 4-layer, that'll do. So I just know at a glance which board is what. Frontside silk. That'll do. Where should I put it? There we go. Just whack it under there. That'll do. DaveCAD 4-layer. Alright. File. Save. Yep, good to go. Alright. Yeah, I won't. I'm not gonna. This is not going to be a tutorial on how to do a PCB. The steps going through for getting your PCB made. It's past DRC. for those who didn't see it, it's past DRC. It's fine. And there's no unconnected jobs. I like the fact that it has list unconnected as separate to the DRC. It's kind of good. You know, because they are kind of different steps, you know, in the check-in process after you've finished a board. So I kind of like that. You know, like a DRC will find unconnected stuff, right? I don't have any errors now, but I presume if we ran start DRC before with those floating coppery bits and stuff like that, you know, it would have picked those up. Let's try it. Huh? Place. Line. Trace. No, hang on. Front copper. Sorry, I don't know like the shortcut keys for this. Yeah, you know, it literally is. All right. Oh no, hang on. Oh no, we're silk. We're on our silk. There we go. Got to select the correct layer. Sorry, I'm. What? It's gone back to our silk layer. Select copper layer, right? We're on our copper layer. Place. Oh, okay. Right, because it knows it's a line instead of a trace. That's why I was a bit confused. Right? Because so it knows that if I'm placing a line, boom, it jumps back to the nearest layer that has lines, which would be the silk, right? Because it's non-copper. So that's interesting. So how do I place my track? Track display mode. What's track display mode? What's K? Oh, yeah. Right. That's the thing I was thinking of before. I thought there was another layer on top of that. Okay. Add new track. X. Why is there no place track under there? Am I blind? Am I like... I need to click that bug thing. Perform... Ah, DRC is up there. Right. Okay. Right. So, X. There we go. Beautiful. All right. So, I've got our floating copper. All right. And net. Okay. Let's just put it to H, right? Okay, so we've now got our error. Okay? Look at that. Automatically comes up. Sweet as. No worries. Alright, so we go to our DRC and we start our DRC. Ah, they're different. They're two different processes. That's interesting. So, okay, I guess it makes sense. If your design rule check, it is your design rules. It's not connection-based thing. But anyway, yeah, so they've decided to separate those. Okay, I've got no complaint about that. It was nice to check that. Okay, so if we list the unconnected, boom, there it is, right? Okay. I've got no issue with that at all. I was curious to know, curious to learn. All right. Hang on. Oh, look at that. Look at that. Okay. Like, for all the smarts in... Apparently, you know, it's all got, you know, whiz-bang, super auto, interactive auto routing and stuff like that. It can't do a simple thing like straighten that trace, right? It should know that I'm being a fanny fuss pot and I've moved my cursor over to here. It should know I intend to make that flat, okay? But it's just rigidly sticking to the rules in that, to the snap grid. Just rigidly sticking to the snap grid. And is there a way around that? Break the trace first? No, I don't want to break the trace first. That's bullshit. Okay? No. This is... No. This is just wrong. No. I should not have to break that trace and then rejoin it or whatever. I should just be able to take that trace, drag it, and it should overrule... Can I do... Nah, Shift, Alt, nah. Hold it down. No. Oh. No. Okay. No. No, it should know. It should know that I want to straighten that up. It knows where my cursor is, right? It knows where my cursor is. It should know that I'm over that. Oh, thanks for telling me that. I'll join it straight across. All right? No, I don't want to use X and draw a new trace. No, I don't want to change my grid size. See, no, I'm sorry. But as somebody who worked at Altium and advised on this sort of stuff, okay, that was my job at Altium, is to advise on this sort of stuff, is that this is not how a professional PCB designer wants to work, okay? A professional PCB designer, to fix that, does not want to have to break the trace. They don't want to have to delete the traces. They don't want to have to dick around with their grid size. They don't want to do anything. They want the software to know their intention and overrule the snap grid. That's what they want to do, okay? Yeah, I know KiCAD's not Altium, and this is constructive feedback to the KiCAD team, okay? Is that something simple like that can make the routing experience much better, right? I've come into this package cold. I know nothing about this package, but as a professional PCB designer, that's what I want to do. A simple thing like that, and you're forcing me to either break the trace or change my snap grid. No, wrong. Please fix it, okay? I mean this it's not criticism of, I mean this in its constructive feedback to the KiCAD team. Richard asks a good question. Why did a professional PCB designer put traces off grid? Well, I didn't design this board, but there are many reasons why you would do that, because you're very often changing when you're designing a board, especially a complex one, you are changing your snap grids and visual grids all the time. You are changing them all the time for various reasons that I won't go into. Like, you're mixing imperial and metric components, surface mount and through hole. You're doing all sorts of other stuff. You're working on high density stuff versus larger stuff like that. And there's many reasons why you might have a grid traces off grid and stuff like that, especially when you're doing interactive auto routing and stuff like that, which won't you can overrule the grids and stuff like that. So there's many reasons why you want to do that, and so I should not be forced to have to change the grid to match that. It's just dumb. It should do it. I'm sorry. Okay? Constructive feedback to the KiCAD team. Unless I'm completely wrong and then there's a way to do it. But I'm sure everyone would be screaming at me if there was a way. Yeah, no, okay, Glenn, fair enough. Submit my suggestions to KiCAD. Mate, what I might do actually is I might edit this video, edit this live stream. I've got a recording of it. I can just download it and then just take out all the crap and just leave in my comments, stuff like that. Thanks, James. Jane, sorry. Jane says I'm right. Of course I'm right. I know what I'm talking about. No, yeah, it's just lower it enough. Oh, okay, you lower the grid enough, but I shouldn't have to. I shouldn't have to touch the grid. That's the entire point. It's the entire point. And trust me, any professional PCB designer, I guarantee you, will agree with me. Guarantee you. Anyone who's done any serious large-scale PCB design would absolutely agree with me that you shouldn't, to change that grid is just it's going to cause frustration in using the tool. Just draw a new one. I don't want to have to draw a new one. Why should I have to draw a new trace? That is ludicrous. Okay? I should just be able to drag and tidy up. This is a step in the PCB layout process, is going through and tidying up stuff like this. Okay? Because you might have all these residual things left, you might have these residual things left over because you've moved, you know, you've pushed and shoved or routed and you're moving all over the place. And as a final pass, you're going through and you're just tidying up stuff like this. And, you know, it should be trivial to do that. And it's not. Okay? And I know you might think it's trivial, just change the grid size. Just delete the track and place a new one. Or just place a new track. It is totally beside the point. Okay? Trust me, if you had this, you saw the difference in productivity on a huge board that has thousands of components, tens of thousands of traces and things that you have to tidy up as a professional PCB designer. Right? Okay, I can do this, right? Whoop. No, I can't. Oh, do I have to drag it? What? I'm trying to place a new track, right? I'm doing the X thing. Ah, there we go. Okay, it got rid of it. It's kind of groovy, but no. Anyway, undo. But I shouldn't have to place a trace. I should just be able to drag it around. See, when I placed a trace, it was the wrong width. Meh, it didn't even do the pickup. Okay, I'll ask this. Does KiCAD have the ability to automatically pick the existing trace size from the trace I connected to? See, a professional tool would know that when it will at least give me the option to have the ability to automatically pick the trace size and overrule the current trace size to the track that I'm editing, right? Because, generally you do not want to make it to neck that down, which is what it's called. That's the industry term for when you go to a thin trace to neck it down. There is a button for that. Drop down trace sizes. It can. Button at the top. There's a button at the top. Display polar coordinate. Oh, there's a button at the top. What? Button at the top? Sorry, I'm show pads in outline, show wires in outline mode, show tracks in outline mode. High contrast display mode. No, sorry. Auto track width is the button under the DRC button. Oh, auto track width when starting to use its width. Otherwise, thank you. It's got it. It's got it. Okay. Okay, so you got to enable that. Okay, that's groovy. All right. Well done, KiCAD. Nice. Look at that. Did it. Fantastic. Okay, happy. But I'm not happy that... Sorry, I want to undo that. But I'm not happy that it doesn't allow me to drag. And, yeah, it does have features. Yeah, I will stand corrected every time. I have not used this, okay? This is literally the first time I've used KiCAD 5. Literally. I'm just, adding my commentary as I go. Now try drawing a new trace from out 4 to under red, right? All right. No, I get, we could go into this forever. I don't know if I'm in OpenGL or view mode. Push the lowest connection up should fix them all. Yeah, but I want to drag just one. I want to drag one. How do you push? How do you push? And if it did push them, then if they happen to be the same spaces, it might work. But then again, it might not if they're a bit higgledy-piggledy. KiCAD needs a do what I mean mode. Look, I'm not bad-mouthing KiCAD. It's a very impressive and usable package, okay? I just want to make that clear. From my, just using it for the last hour and the previous time that I used it. I know, as a professional PC engineer, it's a very powerful and capable package. There's just, I just offer some constructive feedback in things. Drag, but one is limited to the grid. If dragging multiple, it will go beyond the grid. Okay. Iggledy-piggledy. Drag item or drag track. Keep slope. Yeah. There you go. There you go. Didn't... See? Ta-da! So yeah, I just want the ability to be able to tidy up my work. It's not my work, but Anyway, enough dicking around. Right, so okay. How do we generate Gerbers? Let's generate our Gerbers. Sure, there's probably a print board. Is that it? Print? Is print Gerbers? Or is print? Generic options. It looks like print. Looks like paper print. That is paper print. Can you PDF? Anyway, export. Spectra scan. GenCAD. Oh, sorry. There you go. Just have a look around. So I can import Spectra and DXF. Can export Spectra, GenCAD, VRML, and step. Footprint association. Fabrication outputs. Footprint position. Drill file, footprint. Netlist file, a bomb. Okay. Plot. Output. Gerbers. There you go. Alright, so... Okay, whoa. Sorry. Wrong screen. Alright, so this is our PostScript. SVG, DXF. Wow. PDF. There you go. Yep. That's it. Nice. Alright. So, generating our Gerbers. You want our FCU. Love it. VCC, ground, our copper. And we don't have an adhesive layer. Don't have a paste layer. We only have a top silk. We don't have a bottom silk. Solder mask. Front and back solder mask. Front and back solder mask. Drawings and edge cuts, which is our board outline. I think that's all we need. Pretty sure that's all we need. That's all we need. Have a delivery. Hang on. Cool. Thank you. Thank you. Appreciate it. Cool. Just a delivery of more microcurrents. Okay, now we've got copper, VCC, ground, BCU. Does anyone... Am I missing anything? Drills is the bottom button. Oh, you can run DRC from here. That's handy. You should have already done that. Save reports, generate drill files. Okay. Gerbers. Plot. Okay, do we need to generate drill files first? Okay, bottom right. Yep. Generate drill files. Okay, so we've got our layers. We've got top copper, inner planes, bottom copper, top silk. There is no bottom silk. We've got our top and bottom solder mask. That's all we need. And our edge cuts. Edge cuts. Just weird names. Should be like board outline. Something like that. Edge cuts. I don't get that. So generate drill files. Okay, we've got our Epsilon format. Inches. Doesn't matter. Drill map file format. Okay. And mirror Y. No, we don't want an absolute. Auxiliary, we don't want an auxiliary axis. No, we want absolute. Decimal format. Suppress leading zeros. We're not fussed in that. Precision 2.4. That'll do it. Generate drill files. I think all the defaults are good to go. Plated through and non-plated through in single file. I don't think we have any. Oh yeah, there's 5 non. There it is. There's 5 non-plated pads. That's all right. I'm not fussed. This is not a production board. Generating. Gerbers. Oh no, yeah, no. It created separate files. There you go. Created plated through hole and non-plated through hole. Nice. All right. So there are our drill files. And all right. Check the option to combine them. There was an option for that, was it? Oh, okay. In single file, not recommended. Only used for board houses which ask for merged. No, I always do them separate. You want to do them separate. The PCB manufacturers know. Like, you don't have to muck around with that. So anyway, yep, done. All right. So I've generated our drill files, and then it just plotted. I expected it to ask something. It just did it. So our FCU Gerber is created. Our VCC, our ground. I like how it names them. That's good. F silk, F mask, Gerber, edge cuts. It's all good. I think we're probably done. Does it have a Gerber viewer? Anyone? Bueller? Anyone? Really? PCBWay asked for a combined. Why? Why can't they just do it? Why can't they just take both files and import them? Yes, in viewer. Yes, in the launcher. Blah, 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 blah. Okay. So, we're done. Close. Closed. Okay, so someone said it's in the viewer. All right, let's go to the viewer. Gerber viewer. Yeah, there it is. Yeah. No muckers. Enable acceleration. Yeah. Okay. We're in like Flynn. All right, here we go. Oh. Okay, open Gerber files on the current layer. So I've got to open them, do I? What's pretty? Rescue backup. Wickerlib pretty. What Gerbers? Okay, there we go. Created them today. Oh, yeah, these are the original ones. Okay, so we don't want those. Okay, can we open multiples? Yep. Yep, we're good. Hey, we're in. Okay. Can I delete, you know, all that? Whatever. I don't think... Here we go. This Gerber viewer's alright, isn't it? Does the business. Let's have a look. I'll just... It's overlaid them by default. Look at that. There you go. Does it have any like any checking, any design, or is just a viewer? Yeah, it's not a professional production tool, and stuff like that. It's just a viewer, just fine. Show grid, sketch polygons, show decodes, show negative objects, decodes, external. Yep, get involved. Let's get involved. Contribute, developers, docs team. Alright, so there you go. That looks groovy. Okay, it's showing the outline here. Where does that come from? Showing the I didn't think that we printed. Didn't think that we printed the. Why has it got the sheet on there? We didn't print a sheet, or is that generated in the just the Gerber viewer does that? Can someone tell me? Oh, it showed the sheet before I imported. Thank you, Clayton. All right. Yeah. All right. Yeah. It did, because I was just confused. I didn't think that it was possible for it to do that. There's our edge cuts. Edge cuts. I find that just that name fascinating. No. So yeah, the Gerbers look good. They're all lined up. We didn't goof anything. And because you can goof it up with absolute origin versus you know, a other reference. So there you go. And we want to check for our pullback. Like I said, here's the important stuff. Okay, you do not want this copper to go right to the edge, because if you do, especially on a multi-layer board, and especially given that the inner planes are usually on a pre-preg, a very small pre-preg it's called, very thin pre-preg. They're usually quite thin, actually, together. So when you saw the edge of the board off, or route it off, or do whatever, yeah, you can get the burrs and you can easily short out your copper planes. So, huge trap. Many people have come a gutser on that one. Yeah, so you want that. You do not want that copper to go to the edge of the board. So, oh, Rev 1749, didn't see that. There you go. Oh, look, it's added. Why is it surrounded D29, D29? Look at that. Not sure what's going on there. Actually, that why is that not a? The pad didn't look like that, did it? The pad didn't look like that in the PCB Designer. Hang on. What the? Wow. Is that a Gerber rendering issue? Gerber command IDs, yeah. Need to add more chamfer sections or something. High quality / low quality. Oh, okay. Is there a view thing? Is there?
Is there a high quality mode? Not fussed. Basically, we just want to know that the you know, the Gerbers are all lined up. Nothing looks out of place. There's no dags. There's our VCC layer. So I think we're good to go. I think we're done. How long's this video been going for, by the way? Are we over the magic 2 hour mark? I started streaming 2 hours ago. Yeah. If it goes over 2 hours, YouTube takes longer to process. Anyway, we're done. That's it. I should stop yapping now. Oh, that needs to be done in the PCB layout. Did I? Oh, okay. Right, that was actually at the PCB level, was it? Okay. PCB plotter used low. Okay, so it occurred back in the PCB stage. Low quality polygons for speed. Okay. There's 1632 selection for how many segments on a circle. Okay. Thank you, Lucas. KiCAD does not seem to export circles on planes. Okay. Right. Cool. All right. Thanks, guys. I think I'm done. I'll get this board manufactured. Actually, can we do this? Hang on. Hang on. All right. So that's the Gerber viewer. How big is the board? Sorry, let's just, might as well finish this off. Let's go all the way with LBJ. And how big is the board? Can you give us dimensions? Anyone? Can it give us like inspect? I know we can measure, but I want to see if it can do it from the cuts. You know, edge cuts. Is there like a board information thing? Display options. Is there a board information? And tool in the bottom right. No, yeah, there's a measure tool. Yeah, no, I don't want to measure the distance. I want it to automatically give me stats about my board. Because it knows how big my board is. It's got that edge cuts outline. I want it to be able to tell me. Does it have that ability? That'd be nice. I would like it to just tell me your board is X by X. It's got 2,000 components. And yeah, no, yeah, it's place measure tool. Okay, you know, that looks like the only thing you can do. All right. 9.3 in. I've got to go to imperial mode. Metric mode, sorry. So it can't snap. I don't like that. See, it should be able to snap. It knows I'm on the... Oh, thank you, Potato, for your $10 super chat. That's generous. I love your videos and I've learned so much. I've been working with Eagle for about 5 years and just recently switched to LDM and want to take my boards to the next level. Any tips? I don't know. I've done, as I said before, early in the stream, I've done a... But if you already have 5 years experience using Eagle, but I've already done a video. It was part of my power supply design series, laying out a board, and it's like walkthrough commentary, laying out the board. And I've got manufacturing design rule videos. They're massively popular. It's one of my most popular videos. It's got like 800,000 views or something. It's huge. I've done a couple of those. Like there's at least part 1 and part 2 for the manufacturing design rules and stuff like that. Panelization is a big thing, part of the production side of stuff. You know, panelizing things, if you want to take your boards to the next level, is integrate a test solution into them. And I've done a video on that, how to integrate test into your boards, like edge connectors, so that you can plug in test jigs and test, you know, 10, 50 boards all at once on the panel, which, you know, so yeah, maybe, you know, if you're serious about it, go get do the IPC certification course, get the CID certification. I'm a CID certified PCB designer, and I think so. Yeah, they often run in. It depends where you live and stuff like that, but they're not cheap. But if your company can pay for it, maybe they've got a training budget. They have to spend their yearly training budget. If you're doing PCB design at work, I would highly recommend the CID course, for example. How do you know the size of my board? 9.25 by 6.25. Yeah, so those things I recommend to take your PCB design into the next level is knowing about production, knowing about, you know, things like that. Anyone can lay out a board, right? But, you know, to know about getting boards manufactured and tested and things like that with the utmost efficiency, that's where the value add comes in for a professional PCB designer. Is there a... Oh, potato, you're a 16-year-old. Really? Is there an... No, I don't think there's an age limit. They'll happily take your money. It's not cheap. It's not cheap. It's like it's a multi-day course. It's a professional multi-day course. It's not going to be cheap. I forget, but yeah, at 16, okay, yeah, all right. Well, that's a different thing. You wouldn't do it at 16 probably, unless you find someone to pay for it for you. Oh, you did. Thank you, Bopstick. You're the one who sent me the files. Thank you. Of course you know. Right. I don't... Inches. What's that in millimeters? What's that in millimeters? Alright. Let's go over here. This will be the final thing for the day. Let the way. Okay. Dimensions. Oh no, input. What was it? 9.25 by 6.5. Was it? 9.25 by 6.5. 6.25. 9.25 by 6.25. 9.25 by 6.25 inches. 4 layers. Quantity. Just need one. Least expensive color. Yeah, let's just go least expensive color. What can we get this for? Silk screen just on the top. I don't need bottom. Cheapest finish. Yeah, give me a cheapest ass finish possible. None of that gold flash rubbish. Okay. Board thickness. Yep, standard board thickness. 2 mil. Oh, really? You can't even go above, like, you can't go to 2.4 or anything. You can't do any thickety doodad boards. It's a shame. 1 ounce copper, 6 mil, trace and space. I think we're 10 mil. Like, we're 10 thou or something. But I'll just leave it by default, whatever. Like 8. I don't know. I don't know what the design rule thing in this one was. Minimum drill size. No one does drill size in inches. Rubbish. Anyway, I'll just leave it by default. Gold fingers. No, we don't have any gold fingers. Number of designs separated only by silkscreen. Quality certifications. No, we don't want any of that. Rubbish. I want quality certified. China versus Taiwan PCBs. Ding, ding, ding. Fight it out. Yeah. Yep. No, we don't need a stencil. Don't need a stencil for my through-hole design. Ship to Australia. Alright. Here we go. Ship to Australia. Board arrives in default time. Get prices. Here we go. Yep. Yep. Yeah, we just want the cheapest ass finish. I don't care if it's lead or not. They're not going to give you lead by default. They're going to give you lead free. PCB way. Some of these are spammers. In fact, probably most of them at some stage. No. But some of them. PCB way have spammed. JLC PCB, I think they've spammed as well. All PCB, yeah, no doubt. I think they've all tried to spam the forum. Make sock puppet accounts. I don't know what it is with PCB. Chinese PCB suppliers. They're like, I don't know. They're just obsessed with making sock puppet accounts. Thank you, Dark Matter. For your super chat. Okay, Aussie bucks. Here we go. China Post. 45 days. 234 bucks. Whoa. That's... JLC PCB. This is what I found last time. The cheapest price. Oh, it's an advertisement for PCB Way. Okay. Sorry. Yeah. PCB Way have paid to get right up the top of the list. Yep. So but otherwise they're sorted in price. Yeah. Look at this. Yep. Yep. So it's anywhere up to, look at this, $700. Advanced PCBs in the US, but they're going to do a good job and they're going to turn it around quick. Breadboard killer in Australia, $600 because they're good for like little boards, little tiny. That's their thing. But this is a big board. See, people think PCBs are cheap, and well, they are compared to when I was a boy. But because people make, everyone does little bloody Arduino-y things these days. This is a decent sized board, right? This is a real PCB, right? So, like, even dirty PCBs, people think they're the cheapest on the planet, right? So, like, a lot of dirty PCB fanboys, for example, not, bashing them. I'm just, I hear a lot. Oh, yeah, dirty PCBs. Get a PCB for $1. It's practically free. Or whatever, $388, right? Because their whole process is set up to manufacture, their entire business model relies on the fact that they can fit 50 different designs on their one panel, this big. One's called a panel this big. And and when you come along, smart ass come along with your big ass PCB like this that takes up most of the panel, and they're going to go, screw you. It's going to cost money. So, but check this out. I mean, this is insanely cheap. JLC PCB, Easy EDA, they're the ones who have that online Easy EDA thing, but they also have a PCB service. I don't know if they do it themselves or they farm it out, I'm not sure. But anyway, it's insane. $87.50. And I get 5 of them. 5. I get 5 boards of 9 inches by 6 inches, 4-layer, for $87. That is insane. When I was doing, it's like, for me to get 10 years ago, to get a 4-layer board manufactured, just one, probably would have cost me $1,000. This is insane. Insanely cheap. So, yeah, I'm going to use, I think I'll use JLC PCB. And 24 days I can get DHL Express. 100, of course I'm going to go DHL Express, right? For the extra $10 or whatever, $13. You're damn straight. Because I got a DHL dude that comes here every day. And I'm going to get my boards in 9 days. In 9 days, 5 of them for $87. 4-layer large. That is just... wow. Wow. You young whippersnappers these days, you have no idea how good you have it with your online bloody shopping and your super duper cheap ass PCBs and your mouses and your DigiKeys and everything else. It's just it's ludicrous. That is nuts. Anyway, so there you go. So that's it. So I'll probably use them. I won't go through the process of getting it made now. Well, I will after this, after the live stream. So that's it. Thanks everyone for joining me. I'll call it quits there. And, yep. Now get off Dave's lawn, yeah. Yep, that's crazy. That's just nuts. Unbelievable. And hopefully, see the video I do, hopefully I'll get, I'll probably get about $50 in ad revenue from the video, unless it gets very popular, you know, so it almost pays for the boards, you know, to get made. No worries. Thanks, Adrian. Yeah, I kind of pee it. Yeah, I kind of... I'll probably get around to it. I want to do like a demo board. Actually design a demo board and then actually go through and get them made and have like a PCB manufacturer shootout. But unfortunately, it's one of those videos that doesn't... that dates, right? As soon as I release it, 6 months later, it's just not... May not be complete, you know, I may as well delete it from YouTube because it's useless, you know. Please do more of these streams. Oh, no worries. Potato. Yeah, I haven't watched all the JLC Factory Tour on Stranger Parts yet. I saw that it was there and I watched a minute or two here or there. Yeah. Yep. JLC PCB claimed to be the biggest PCB prototype house in China, and that's a big-ass claim. So, yeah. Yeah, I'm not going to bed. What is it, midday? No, it's 11 a.m. Suze is laughing at you. Hang on. Suze is over there. Say hi, Suze. There you go. Alright, so enjoy the rest of your day, Dave. Thank you very much. Thanks, guys. Thanks for joining me. Yeah, you're a bit late to the party. You just came in. It's bye. How many people did we end up getting watching the live stream? How many? Still 548. I think we hit like 800 watching or something. Which isn't too bad. It's alright, cool. Alright, thanks everyone. Catch you next time.